Okay, so this is the distance formula here. You may have seen it before, like I mentioned. You don't necessarily have to memorize this formula because it is on the reference sheet for the EOC right here. But you do have to practice using it because there's just a lot of little parts that can go wrong. So the more you practice it, the better you'll get at using it. So first things first, we need to identify the two coordinates from the graph. And if you look closely, there's 0.1 and 0.2 right here. And so what we're doing is we're finding the distance between points, literally exactly what it says. So you can use your ID to just like connect the dots to give yourself a visual. You want to know the length of this line. But because it's like on a diagonal, we can't just count the squares because the diagonal of a square isn't the same as side of square. Okay, so what we're going to do is take the coordinates off the graph. So 0.1 is at 1, 5. We just write that down. And 0.2 is at -5, -1. And then we are going to label the coordinates. So the first set of coordinates will be x1, y1, and the second set is x2, y2. Whichever one you designate as the first and second set, honestly, it doesn't matter because distance, whether it's forward or backwards, is still going to be positive and it's the same thing. Just on this worksheet, it says P1 and P2, so we'll stick with that to stay consistent. Okay, so then once you have it labeled, you can plug the numbers into the equation just as is. So distance equals square root x2 is at -5 minus x1 is at 1 squared plus y2 -1 minus 5 squared, like that. Okay, and then once we have this set up, we're going to follow order of operations. So we have to solve what's in the parentheses first. So this would be -6 squared plus -6 squared square root. -6 squared, -6 times itself would make +36 plus, again, +36. Add these two values together, we get 72. Depending on the resource, they might have you just put in the answer as a square root. Actually, on Alex this week, it'll ask for just the square root. But sometimes they'll ask for the decimal. So what you have to do is plug it in a calculator to get the decimal, which is what Liam's doing. Okay. If you don't have a calculator, it's not a huge deal because I'll just tell you the numbers at school. Okay, so 72 square root be 8.49 is what I'm rounding to. So it was 8.485, and then because this is 5 or higher, 8.49. And then these little squiggly lines means it's a rounded answer. I just rounded it 8.49. It means it's like rounded, approximate. Yeah. This is technically more exact because you didn't do any rounding. Okay, then we repeat the steps. So here we have 0.1 and 0.2. Connect your dots. Give you a visual. Finding the length of this line. 0.1 is at 2, -2. And 0.2 is at -5, 3. Then make sure to label your points x1, y1, x2, y2. Okay, so what I want you to do now is practice plugging in the numbers into the equation. Also note that there is a subtraction in the equation. So, yeah, anyways. So try it yourself and we'll compare answers in like 10 to 30 seconds.
On what, question 2?
Yeah, so just plug in the numbers into the equation and then we'll compare and make sure we're getting the same thing. Okay, this is what I got. So compare yours to mine. This double negative, 3 minus -2, we're going to add the opposite. And then we'll solve here. So we get -7 squared plus 5 squared. Then 49 plus 25. 49 plus 25 is 74. Square root of 74 is 8.60. Okay. Next one, same process. Point 1, point 2. Connected dots. 1, -3, 3. And point 2, -2, -4. Try it, see how many steps you can get through on your own. I'm going to freeze it and then we'll compare in a second. So you're going to label your points. And then plug your numbers into it. I'm getting square root of 50. Is that where you guys are at?
Yeah.
Cool. Here's what I got. You didn't get to square root of 50. Just look at where it went wrong. Like there's a lot of little details that could get messed up. You could put numbers in the wrong place. You could subtract the negatives wrong. There's a lot of little things. They're all simple, but it could be anything. Okay, the last one here, start it from the top on your own and see if you can get it. 1, 2. I'll try to work a little bit behind you. Or if you're still needing step by step, I'll just slowly work through the steps up here. Yeah. Feel smart now. Okay, so we got 6.08 or square root of 37. Good job. Okay. When you're ready, just yeah. What do you mean?
The number?
Did I not? Did I 37 square root? Oh, that's what I did, right?
Yeah, you're not doing it. It's not good.
I was doing hundreds the whole time, so either way is fine. Usually it would say if it mattered, so you just choose. Okay, on the back, we're gonna just continue working through the steps. Okay, so on the bottom here, the bottom four, we're gonna do the same thing. So we'll just write the distance formula down once so we can reference it. So we'll write it down here. Distance equals square root x2 minus x1 squared plus y2 minus y1 squared. So we're just going to continue. Based on like my experience with our other classes, like at this point, about 50% of you are good and 50% are still working out the details. So I'm just going to continue working step by step for those that need it. Yes, Matthew.
What?
C.
The top 6 that we were doing.
We'll do that in a second. So we're going to just stick with this skill where we're at it. Great. Yeah, like hard to get us all in sync. Okay. Have the distance formula down, then we're going to label x1, y1, x2, y2. And then I'm going to plug my numbers into the equation. Distance equals square root. x2 is -1 minus x1, which is 9 squared, plus 8 minus -3 squared. Add the opposite here. -10 squared plus 11 squared. And here, square root of 221. Comes up to 14.87.
You have to show them.
C. Really smart. Yes, I'm going to come around and check all your work after we're done, so make sure you have it all down. Okay, next one here. x1, y1, x2, y2. And then I'm going to plug the numbers into the equation. 0 minus 10 squared plus 4 minus 0 squared. I'm feeling like I'm going too slow and you want to work ahead. More power to you. $16. I think you got 10.77. That is correct. Number 7, same process. x1, y1, x2, y2. Did anybody already finish this one?
Which one?
7.
I just saw the answer.
Okay, you got 17.03. Good job.
17.09. There.
290. Okay. Anyways, okay. So plugging this in, distance equals square root x2 minus x1 squared plus y2 minus y1 squared. $169 plus 121 is 290. And then you take the square root of that, and it gives you the 17.0. Great. Start by labeling. If I don't label, I always mess it up. So label it. Okay. If you're missing like a little part or something, I can show it at the end too. Right, did you move? Okay, ready for the next part or no? Okay. So that's distance formula. There's actually two ways. I'm sure there's more than two ways, but there's two primary ways to find the distance between 2 points on a coordinate plane. Distance formula is one of them, and the other way is using the Pythagorean theorem. The Pythagorean theorem way is a little bit easier, and it's definitely preferable by students. One year I only taught the Pythagorean theorem way, and I totally regretted it because as far as standardized testing goes, they will find a way to make sure that you know how to do distance formula. So they'll give you numbers that look like this or something. You don't have to write this down, but they might give you numbers that look like this, where graphing those points wouldn't be like logical or make sense. It would make sense to use the distance formula. But if the numbers do fit on a graph, Pythagorean theorem is a great way to solve this and make it a little bit easier on yourself. So you may recall Pythagorean theorem is the equation a squared plus b squared equals c squared. Write this down now. Should sound familiar. It's come up a couple times at this point, I believe. And Pythagorean theorem is used with right triangles, and you can use it to find the length of the side. So the two legs of the right triangle would be a and b, and then the hypotenuse is c, and then you can use this equation to find the side length of the triangle. What does that have to do with this? Well, if you have a line on a coordinate plane like this, you can sketch out a right triangle and then use that to find this length, which would be C, the hypotenuse, the triangle. So this would be A and B, and then this is C. So the length of A here would be 3 units, and then B is 1, 2, 3, 4, 5 units. And then using Pythagorean theorem, I'll solve for the hypotenuse. So it'll be 3 squared plus 5 squared equals c squared. And then from here, square root of both sides, and c equals 5.83. That is the length of this. So it's a lot easier to work with, and there's less errors that can happen. But again, it won't work in every single situation, but it'll work in a lot of situations. Okay, so number 2, we're going to find the length of this, and we can do it by just sketching out a right triangle here. And so 1 by 1, 2, 3, 4, 5, 6, 7, 8 units. And just 1 squared plus 8 squared equals c squared. Take the square root of both sides, and c is 8.06. So that's this length here. Okay, on the next example, I want you to sketch out the triangle on your own and see how far you can get with it. I'm going to also do it on my paper, and then we'll compare. So for number 3, sketch out your right triangle. Count the units. Yes. Either way, actually. Yeah, either way will work.
Wait, so any of the two missing sides can be, any of the up and down or the right, left, that can be A or B.
Yeah, so like I drew mine like this, which I found like a lot of students are drawing it the same way, but you could also draw it this way and you would get the same answer. Like it's fine. Because the dimensions would be the same, 4 and 6.
No, but you can make 4 and 6, A and B, or B and A.
So yes, A and B are interchangeable. It's just C is not. C has to be the hypotenuse. Yeah. Um, 4, 5, and 6, like, you're welcome to work ahead of me. I'm just gonna work through it step by step. If you want to work with me, that's cool. If you want to work ahead of me, that's cool too. So I'm just gonna finish this up. Sketching out the right triangle. I have 3 units by 1, 2, 3, 4, 5, 6, 7. 3 squared plus 7 squared equals C squared. Okay. So what I'm going to do is I'm going to go around and check your work. If you did all the work on your paper, I'll give you like a star on your paper. That means you get full credit. If you didn't get full credit, I'll let you know. But yeah, I'll keep this up on the screen as well. So if there's something you're trying to get filled in that you didn't get a second chance to, you can fill it in. For the last 20 minutes of class, I'm going to have you work on your